Okay, we are in 10.4. Today we're going to be focusing on how to determine if you have triangles that are similar. But before we get too far into that, I'm going to read you our joke of the day. Here's your joke. I love optometrist jokes, but they keep getting cornea and cornea. Okay, that's pretty good. So you're welcome for that gem of joy in your life. Okay, so first thing, in order to determine if something, like if two shapes are similar, we have to know what it means for shapes to be similar. So if two shapes are similar, this means that all angles are congruent. And all side lengths, or all sets of side lengths, are proportional. We've talked about this before, basically all the sides are multiplied by the same scale factor. That's what you're going for. Okay, so we're just going to kind of use that definition to guide us through the rest of this. So there are three different ways we show similarity. First, angle-angle similarity. And here's what this means. If two sets of corresponding angles are congruent, then the triangles are similar. So if you look, for example, over at this picture on the right, over here, I see I have angle A is 59 degrees, angle B is 37, A prime is 59, and then it says C prime is 84. And so I can look at that and go, well, I see that these two, wow, okay, sorry about that, getting crazy. Okay, I see that A and A prime are congruent. Well, to find the measure of the other angle in the triangle, this is like 10.1, where I know that all angles add to 180 degrees. And so with subtraction, I can actually find that B prime is 37. And I don't even have to find that third one, because here's the deal. If two angles are congruent, and they always add to 180, that third angle also has to be congruent. So I know that these are similar triangles because all of the angles are congruent. I think sometimes the hardest part of math is not necessarily the steps, but like knowing when to do each step. So I put in this part, I should use it when. Here's what I think you should use angle. When no side lengths are labeled. So that if you have no labeled side lengths, that's a big hint that you should probably be looking for angle-angle similarity. So let's take a look. We just have to state if they're similar or not, and we're going to complete the similarity statement. So that's where we say which angles go with which. So let's take a look at example A. Remember, these markings mean that those are congruent. And so K and E are also congruent. So two angles, that's all I need. And so, yes, we can say that these triangles are similar. So I'm going to fill out the statement by first drawing the triangle symbol, because we've got to represent a triangle. LKJ. Well, L went with D, so I'm going to write D. And then K went with E. So D, E, and then looks like J goes with F. And all I'm going to do is say by angle similarity. I'm going to write similarity because these theorems we're going to use are similar. Pun always intended, for the record, but it's very similar to congruence theorems, which you talked about last year. So we're going to be more specific with similarity. Okay, part B. Something that I want you to take a look at is we have here vertical angles. I'm fairly positive you've seen those before. Basically, we have the two angles that are across from each other in an X shape, those are going to be congruent angles. So I have one set of congruent angles. Well, 70 and 76, neither of those are 73. So that means one set of congruent angles is not enough. So all I have to do is say not similar. And if you want to complete the similarity statement, we're just going to put a little cross through that similarity symbol. And because none of the angles correspond, we can just write whatever order we want. Party. Okay, example C, just a reminder, here we have some parallel lines. And so we're going to be using parallel line relationships, which it's probably been a hot second since you've thought about those. First thing I see, I got some vertical angles going on. So vertical. And because these lines are parallel, I can actually use a relationship called alternate interior angles. That's a throwback to 9th grade, friends. I know alternate interior angles are congruent. So because I have two sets of corresponding angles, we're just going to match them up. So it looks like, I'm going to just do this with a different color real quick. JKL. So I went to the non-labeled side and then over. So I can see that triangle JKL is similar to triangle JEF by angle similarity. So those are some angle examples for you. Moving right along, we got another one. We got side angle side similarity. Okay, here's what we got. If one corresponding angle is congruent, and the sides that make the angle are proportional, then the triangles are similar. Okay, the biggest piece of advice I can give you on something like this, I'm going to write it in red because it's really important. Because notice I don't have a similarity statement. I'm trying to decide which side goes with which. Remember, with sides, we're going longest with longest, shortest with shortest. Because if I'm multiplying by a scale factor, like if I take the longest side of a triangle and multiply it by a scale factor, there's no possible way that that side is going to not be the longest side of the new triangle. And so I can look, my longest side for the left triangle is 6. The longest side is 12. Well, I know that that's a times 2. So if I go from 5 to 10, well, that's also a times 2. So because it's multiplied by the same scale factor, those are proportional. So we should use this and you can determine one angle is congruent. So that'd be a lot of like vertical angles. And also, when you have two sets of sides that are labeled. So looking at these examples, for part A, okay, I have, two sides and the angle between them. That's what we want. Two sides and the angle between them. So if I take a look at this, oh my goodness, sorry. All right, so because I have a 9 and 9 here, and I have a 36 and a 37, well, those sides would have to be the same if they're multiplied by the scale factor, so I already know that these are not similar. So I can, let's see, E, F, G, I don't know, L, M, N. Doesn't matter which order if they're not similar. Okay, part B. Here I have some vertical angles. Vertical angles are congruent, and I have the two sides that make up that angle, and that's what we want. So I see that my longest side is 30 on the top one, and my longest side on the bottom one is 10. So I can see from 10 to 30, we multiply by 3. So that means to get from 9 to 27, well, hey, look at that. I also multiply by 3. Multiplied by the same scale factor, that means that they are proportional. So we do have some similar triangles here. A, B, C. So I just trace it because it's helpful for me. And the reason I labeled them with like circles and boxes is so I can see which side goes with which. So I can see that A, B, C, I went down the 27 side, which means for the other one I have to go down the 9 side and then over. So triangle ABC is similar to triangle AVU. Okay, for part C, be careful because there are really two triangles here. And I really encourage you to draw out both of those triangles separately, because this one is not hard to pick out the dimensions for, because I got, a 66 and a 54. But the bigger one is the full side length. So I actually have to add those together. So I get a 77, and then I also get a 62. And you might look at this and go, okay, but how do I know that the angles why would I use side angle side here? Well, notice for both triangles, they both share that angle. So angle T between both of those is going to be the same. So now I can just look at the proportionality in the side lengths. So I'll go to green. Okay, I look at this and, I could see that, 67 goes with 77, 54 goes with 62. I don't know the scale factor off the top of my head, so I'll set up a proportion. You go 66 over 77 equals 54 over 62. And honestly, what I do is I just type those fractions in my calculator. Or I can cross multiply and see if I get the same thing. Either one works with me. I'm just gonna, let's do, no, actually, in preparation for next time's lesson, we will just type in the fractions. 66 divided by 77, that's like a 0.86. And we're going to see, it has to be the exact same fraction. So 54 divided by 62, 0.87. Ooh, no, close but no cigar. So I know these are not similar. Put my slash through triangle, let's see, TUV. So if I went big, then I gotta, oh wait, it doesn't matter if they're not similar. Well, anyway, there you go. Okay. So that is side angle side. So now we're going to look at side, side, side. So if all sets of corresponding side lengths are proportional, then the triangles are similar. You should use this when all three sides are labeled. And so once again, I'm just going to be looking for, is it the same scale factor that's going on here? And I'm still going to remember, I'm going to write it down again because it's so important and helpful. Longest with longest. Shortest with shortest. So I can take a look and I see my longest side is 24 and my longest side is 12. Well, I know to get from one to the other, we can just divide that by 2. My next longest is 18 and that goes to 9. That's a divide by 2, which means that 14 is going to go with 7, which is also a divide by 2. So we have some similar triangles there. Okay, we're just going to look, same thing here for part A. I see my longest side is 42, and that goes to 55. I can tell you right now, I don't know what that scale factor is. So I'm just going to go, is 42 over 55. My next longest side is 33. The next longest is 44. So that should be equal to 33 over 44, which would leave 23 over 32. And so we're just going to check each of those fractions in our calculator. So 42 divided by 55, 0.76, and then I have 3 6 repeating. 33 divided by 44, that's 0.75. Not the same. I don't even need to check the last one because I know they're not similar. So let's see, F, G, H, B, C, D. Not the same. Okay. Once again, on this one, I have 2 triangles. I have the small triangle, which gives me a 42, 30, and oh, how am I supposed to find this side here? Well, if the big triangle we know is 55, 50, and 70, well, we can use subtraction because 55 and then this piece here is 22. So 55 minus 22 is going to get us 33. And that's how we can find that. And so because like one triangle is laid within the other, those pieces are going to correspond with each other. I mean, we could also look, 70 is the longest, 42 is the longest. So notice I'm going from big triangle to small triangle this time. It doesn't matter which way as long as you're consistent, because then I see 55 is next to 33, which leaves 50 to 30. And we're going to check if those are the same. 70 divided by 42. It's like a 1.67. 55 divided by 33. Ooh, we're getting the same. Okay, 50 divided by 30. Guys, we finally got one. So these are similar. So I can say triangle K, let's see, KLM. If it follows that path, then I gotta follow KCD by side, 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 similarity. That would be my answer for that one. The next is just a bunch of examples. They're all very similar, pun always intended, to everything you've done before. So the only one that I really feel, we're just going to go over D and F real quick because those are the ones that look different. With part D, once again, I want to bring to your attention that we have 2 triangles. We have the small one, and I have the big one. Here's what I know. That's 78 degrees, that's 78 degrees, but hey, if this is DKL and that's DCB, they both have angle D. That is the same angle between both of these. No side lengths are labeled, so I know that's going to be angle, angle, and those are congruent. So DCB is similar to DKL by angle, angle similarity. Sorry, just double checking, make sure it's all good in the hood up there. Yep, okay, part F, I see parallel lines. So it tells me a lot that we're going to be using, something like alternate interior angles, if that's possible. Or maybe we have corresponding angles. That's when you have angles that are in the same spot between the two sets of parallel lines. So for example, I know that L and F, those are some corresponding angles. They're in the same spot between the two parallel lines, which means those are congruent. Same thing with K and E. Those are also corresponding, so that means I have some similarity there. J, K, L, following that same path, I get J, E, F. And that is 10.4. Feel free to email me if you have any questions.